We will continue our case studies designing a document editor. So we have discussed in the previous videos supporting multiple window systems. So in that encapsulating implementation dependencies. So in continue with the window class must span the functionality of windows from different window systems. Let us consider two extreme philosophies. One is the intersection of functionality, other one is union of functionality. So in the part intersection of functionality, the window class interface provides only functionality that common to all window systems. Here the problem with this approach is that our window interface winds up being only as powerful as the least capable window system. Actually, we cannot take advantage of more advanced features even if most Windows systems support them, but not all. This is the case. Another philosophy, union of functionality. So here we create an interface that incorporates all the capabilities of all existing systems. Actually, the difficulties here is that resulting interface may well be huge and incoherent. So that is the trouble for this philosophy of union of functionality. So even though we will have to change it, for example, Lexi, which depends on it. Anytime a vendor revises its Windows system interface. So extreme is viable solution. So our design will fall somewhere between the two. The window class provides a convenient interface that supports the most popular windowing features. Actually, Lexi will deal with this class directly. The window class always must support the Lexi knows about the namely glyphs. So that means Windows interface must include a basic set of graphics operations. Let the glyphs draw themselves in the window. So we had seen in the previous videos tables Windows class interface that gives the sampling of the operations in that Windows class interfaces. So Windows is an abstract class, concrete subclasses of windows supporting different kind of windows that user deal with. For example, so in this Windows class, application window, for example, application window icons, a warning dialogs are all windows, but they have somewhat different behaviors. So in the behavior wise, all the windows are different. So we can define the subclass like application window, icon window, dialog window. So to capture this all the applications. So here we will discuss there are two subclass like Windows and Windows IMP important. So we will define a separate window class, window IMP classes hierarchy in which to hide the different Windows system implementation. So this we can see in the next diagram. Windows IMP is an abstract class for the object that encapsulates the Windows system dependent code, which is always dependent to the code wise. So in this diagram, to make Lexi work on a particular Windows system, we configure each window object. So with an instance of window IMP subclasses for the entire system. Actually, the following diagram, this diagram shows relationship between the window and window IMP hierarchies. So here we have taken there are two subclasses. One is window, another is abstract class or subclasses window IMP. So that we have taken. So here different rise and device rectangle and draw rectangle. This followed by application window, dialog window, icon window, and this is followed by Mac window, PM window, XW window. So again different operation will be taken here. So by hiding the implementation here, window IMP classes, this window IMP classes, we avoid polluting the window classes with window system dependencies. So these window classes and system dependencies, we are avoiding that polluting. So that is the system dependencies will be different. So which keeps the Windows class hierarchy comparatively small and stable. So actually, meanwhile, we can easily extend the implementation hierarchy to support the new Windows system. Subclasses of window convert actually request into window system are specific. For example, we have used in the previous section 2.0. So rectangular draw operations using the draw rectangular operations of the instance. So here we are taking the rectangle draw the coordinate values of x0, x0, y0 and x1, y1. So here the default implementation of a draw rectangle which uses the abstract operations drawing rectangle declared by window IMP classes. So that we coordinate x0, coordinate y0, coordinate x1, coordinate y1. This then device rectangle which we are taking it as the hierarchy is x0, y0, x1, y1. So this way we need to implement window IMP subclasses. So for example, now for an X window, so that is the window subclass of the X window system and device rectangle. So which might be look like this. So if you take in this code format, so void X window device rectangle open coordinate x0 coordinate y0 coordinate values of x1 y1. So either all return type will be the integer x y w h. So we are taking the 4-point combination round off of minimum x0 comma y1 x0 comma x1 and y0 y1 and absolute value will be taken for x and minus x1 and minus y1 and draw rectangular part with all the corners. So this is the how we can implement Windows IAMP subclasses. So another here PM presentation managerial windows. It is a subclasses of window for a presentation manager would define the device rectangular differently. So this is the segment of code would looks like that void PM window device rectangular. Okay, coordinate x0 y0 x1 y1 and we need to take all the angles here left right bottom top. So similarly we need to declare minimum x0 y1 x0 x1 and y0 y1 and y0 y1. There is no minus because we need to take it all the coordinate values. So this can be now we need to go point L point wise 4 point will be P point L will be taken in the code point 0 point 1. So similarly the point 0 into dot x. So the left right another is again left right of 0 1 2 3 4 4 point top the two top and two bottom. So also like that there is a condition we need to take. So whether begin path which we equal to false, so we use that conditional statement here. And if there is a report that a report error will be getting, else we will get the HPS 1L and 0L. So this is the why this is different X version because PM presentation manager doesn't have an operation for the drawing rectangle explicitly as X does. So instead of that, PM has the more general interface for specifying vertical and multi-segment shape called a path. So we have taken HPS path, and for outlining or filling the area of the enclosed. So now this is the class Windows system factory. So that is configuring Windows with Windows IMPs. So configuring main Windows class followed by Windows IMP. So now we can define the concrete factory which the system Windows. So the code looks like this. Again, how we can implement this. So the next one is in the legacy designs problems, user operations. Some of legacy functionality we know that which is available through the document WYSIJ representation. So here whenever you enter and delete the text, move or the insertion point or then the single select a range of text by pointing to the particular point, clicking or and typing directly in the document or inside the document applications. So here other operations functionality is accessed indirectly through operations in the Lexis pull down menus, which will have the pull down menus, buttons and keyboard accelerations. So the functionality which includes operations for we will having that one opening, creating the new document. So the main part is user operations what we can do it. The one is creating a new document. The next one is opening, saving and printing an existing document. So this is the user operations how we can be use the particular operations in the legacy document. So the legacy document of in the design problems. So the user operations how we can carry out that one. So there are a lot of functionality are available here. So that cutting selected text out of document and pasting it back it. So there are a lot of word in the word paragraph we need to cutting the selected text we know that. So that entire text we need to paste it in the we need to back to the paste. So where we want to desire to paste it. So that is all comes under controls comes under the user operations. Similarly, the changing the font, this is common, and the style of selected text. So wherever we in the word file, for example MS Word, so if you are selecting the particular text, so we need to select it. Control A, it is nothing but all the text will be selected entire page. But selected text means some paragraph or a sentence or word that we need to make it an align. The font size should be increase or decrease of the particular style will be used, what type of style is required. So that and all we can do it is your operations. Another is changing the formatting text, yeah, such as alignment, justification, space, all the space before and the paragraph after, all we can do in the changing the formatting text. Another is quitting the applications. So exit the applications whenever if you open the particular application. So and a lot of operations usually user or the client or the customer expect in the any kind of the lexical document applications. So that and all comes under the user operations. The next thing is command class and subclasses. First we need to define here command abstract class to provide an interface for issuing a request. The basic interface which consists of a single abstract operation which we can call it as an execute. How you can execute that one? So that is called as a single abstract operation. Subclasses of command implement execute in different way to fulfill the different request. So here some subclasses may be delegate part or all of the work together other object, and similarly Other subclasses may be a position to fulfill the request entirely on their own. So to the request, however, command object is a command object. So they are treated as uniformly. So we will be taking it as command class will be followed by the command object. This is the partial command class hierarchy. So we taken that main class command, then execute. So then followed by the subclasses here, paste command, font command. So what we add in all the designing document in user operations, save command, quit command, how you can quit an applications and save the particular text or any changes, and font means we need to what we change the font size and all, and paste, cut and paste of the text. Your operation will be all or execute. So the buffer in front or any kind of the text. So here paste the buffer into the document which will be reserved it, and make the selected text. So this is appear in front of the because font command in front of the new font. Save command actually pop up the dialog box that let's always username document, and then save the document under the name. So next is, so here this is condition quit command. So if document is modified, save and execute, else quit the application. So this is the partial command class hierarchy. So the next is one more menu item command relationship. So actually in the menu item, so menu item can store a particular command object so that encapsulate a request. So we give each menu item object an instance of the command classes, we know that, so that is suitable for that menu item. Just we have to specify the text to appear in the menu item. So that we need to take in the menu item how we can, what we need to have the all the different kind of menu, so that we need to appear in the menu boxes. So here when a user chooses a particular menu item or any customer, so the menu item simply calls just an execute command. So we can call it as an execute command or operations object to carry out the request. So whenever in the menu item a user need to have a particular call, so he need to quit the application, he need to change the application, he need to change the font, he need to change the style, or he need to cut the or select the text, or he need to cut the, so these are all comes under this menu item command relationship. So that the main here class clip and menu item, so here clicked and execute other operations and command should be executed. So this is the command menu item command relationship. So next is undoability. So that is control that in the any document or lexical lexi design pages or lexi documents. So undo and redo options will be there in all the word file or any applications. So which is always very important capability of interactive applications. Whenever we do the mistake in the text when you writing the text or and drawing the particular thing, so we need to immediately erase it. If that is again required, so we can go with the undo ability, we know that. So to undo and redo commands, so we add an execute operations to the command interface. So command interface by default it will be there, so we need to add it. So unexecuted versus effect of the preceding execute operations using whatever undo information. So execute is stored. So in case of font command, for example, execute operations would store the range of the text affected by the font change along with the original fonts. So the next we will discuss the command history. So after undo ability, command history we need to take it. Okay, so actually this is the final step in supporting arbitrary level undo redo, which are is to be defined of command history or list of commands that have been executed, for example, or unexecuted if the command have been undone. Conceptually the command history looks like this. We need to take the, so how you can take that one. So the command history will be looked in the next slide. So this is the command history here. This is the past command we have taken in the circle, past commands and the present. So here each circle which represents a command object. In this case the user has issued for command. So now here the leftmost command was issued first. So if you consider this the leftmost, so this was the issued first, followed by second leftmost, then followed by third leftmost, similarly like this. So this will be, we can call it as the present command circle or command object. So which is the rightmost? The line marked present keeps track most recently executed and executed, or we can call it as an unexecuted commands. So execute or unexecuted commands. So the here to to undo the last command we simply call unexecute the most recent commands. So that we can call it as unexecuted command, we can call it as the most recent command. So after executing the actually the command, so we have to move the present the line in one command to the left. If the user chooses undo again, the next most recently issued command will be undone. So in the same way, and we are left in the state depicted here. So that we can see that past and future. So in the middle of that one it is called as present. So you can see that by simply repeating this procedure we get multiple levels window regarding past, future and present. The number of levels is unlimited by the length of the command history. So the next is last one, spelling checking or and hyphenation. The last design problem involves textual analysis, specifically checking for misspelling and introducing hyphenation point where needed for good formatting. So this is the final design problems in the lexic design. So whenever in the applications like document editor, so textual analysis need to be done. Specifically we need to check the misspelling, misword, so that after that where we need to put the hyphenation and where that point need to be taken, how exactly we can take the good formatting, so that and all. So we need to do it spell checking. So we also want to avoid wiring this functionality into the document structure. Actually this goal is even more important here than it was in the formatting cases, because spelling checking and hyphenation are just two of potentially many kind of analysis, so we may want to do it. So Lexi, to support that, we will have that expand analytical abilities over the time. In case of ad searching or word counting, calculation of facility for adding up or tabular values, grammar checking, so and so. But we want to, so we don't want to change the glyphs classes in this case. That we should keep as it is, and all its subclasses every time we introduce new functionality of this sort. Actually, there are two pieces of this puzzle. We can say accessing the information need to be analyzed, and which we have scattered over the entire glyphs and this document structure. And second one is doing the analysis. We will look at these two pieces very separately. That one is accessing scattered information, and other one is encapsulating access and traversal. So this is the two common thing here. One is accessing scattered information, and other one is encapsulating access and traversal. Now we will take it in depth. Of the first one is accessing scattered information. What is the accessing scattered information, and where we need to take this analysis? Actually, we will take these two piece for the analysis purpose, spelling and checking and the hyphenation. So many kind of the analysis which require examining the text character by character, line by line, or word by word. The actually the text we need to analyze, which is scattered throughout the hierarchical structure of the glyph object. So glyph hierarchies of the object. So here, how we can do that? To examine that text in a structure, we need an access mechanism. So how you can access the mechanism? So as the knowledge about, we know data structure in which object are, how the data are stored. Some glyphs might, so might be in the glyphs are stored, might be in the store their children in the particular linked list, or we can use that even arrays, or other might use the historic data structure, or all about the primitive data structure. So here an added complication is that different analysis access the information in always in different ways. Most analysis will traverse this next from beginning to end, or somewhere end to beginning, but some do the always opposite. Research, a reverse search, for example, need to progress through the text backward. So in the backward direction rather than the forward, and evaluating certain algebraic expression from the left to right, or in order, pre-order, post-order, traversal, already traversal methods, so that we need to information will be scattered. How we can access? So finally that we need to examine the finally we can say that scattered information, how we can check the spelling. We need to take it as a character by character. So this is the one piece of this analysis. The next one is last one, the most important thing is encapsulating access and traversal. So we know that the encapsulated data will be hidden. So of object data stored in the particular object. So we know that our glyph interface uses an integer index to let client refer to particular children. Another thing here, so what is that children can do it? So it may be inefficient for glyph use a linked list. So that is the another problem in the access to encapsulating access and traversal. So an important role of this glyph abstraction, which is always hide to data structure. So children are stored. What way we need to have that? So that we can change the data structure into a glyph classes users without affecting the other classes, that we need to do it. So another ways, therefore only the glyph can know the data structure and the corresponding its operations and their users. So how we can solve this kind of problem. For example, glyph interface shouldn't be biased toward one data structure to the another. It shouldn't be better suited to particular array than to linked list. So we have that is the problem. How we can solve this problem? We can solve this problem and support several different kind of traversal at the same time. So then only we can come out for this kind of solution. So we can put multiple access travel capability directly in the glyph classes, and because entire classes provide way to choose among them, so that we can take it as a particular enumerated, so that is called as an enumerated parameter. The classes, actually these classes of this all the parameter around during the traversal to ensure they are all doing the same kind of traversal. So this is the main thing we have to pass around any information they have accumulated during the traversal. So that is the one thing we need to remember. So our glyph interface so always uses an integer index to let a client refer to the respective children. So in case of implementation, so we need to take void first traversal kind and void next, and boolean is done, and glyph get current and void insert glyph. So these are the implementation point where how we can take it as a first initialize the traversal method or operations first next is done control, which controls the entire traversal. So this is about a brief introduction to the encapsulating access and access and traversal. So after this, in the designing document, in the spelling miss or spelling check and hyphenation, spelling checking and hyphenation. So that will be the, after that, iterator class and subclasses. So iterator class will be having these things. We need to have an abstract class iterator first next is done, and current item. So that will be followed by pre-orderator array iterator and pre-record little and nulliate iterator. So and followed by return type. So this and all we need to have in the iterator classes and subclasses, then followed by iterator pattern. So iterator pattern always pattern capture this type of technique for supporting access and traversal object structure. So whenever these we have that spell checking and hyphenation, so we need to use the iterator pattern, that is one of the always suitable for this thing. Then followed by traversal versus traversal action. So then followed by encapsulating the analysis, how we can do the analysis through the encapsulation. So that is the very simple iterator. So that will be taken as analyzer. For example, if we have a capital letter, a small letter a, then followed by double quote, then followed by one hyphen. So how we can do the encapsulating analysis is iterator through one. So one iterator, and after that, so the node will be divided into the next, then letter A, then followed by the hyphen of that one double quote. So this is the up to the iterator of, and after that one will have in the case studies that final visitor class and subclasses. Again we need to implement that, how we can implement visitor class and how we can take the subclasses implementation. So that is the visitor class whenever you need to require, so that is we need to take it as a visitor. We have a well-known visitor pattern. So this is the end of the case studies of designing a document editor with design problems. So what we have started from the designing the lexical design. So we have started lexi, that is the document editor lexi designs. What you see is what you get. So simply we have taken the document editor code word is WYSIW, so YG, and we have addressed the issues, design problems regarding document structure, formatting, embellishing the user interface, supporting multiple look and feel, supporting multiple window system, user operations, and finally we had spelling checking and hyphenations.